Particle P is moving along OX with an acceleration of negative 9 plus v squared meters per second squared at time t seconds, when its displacement from O is x meters and its speed is v meters per second. When t is equal to 0, or initially, x is equal to 0 and v is equal to u. Find the value of t and the value of x when the particle comes to rest. Okay, well, let's deal with the t first. So we have a is equal to negative 9 plus v squared. That means dv dt is equal to negative 9 plus v squared. Separate and integrate. The integral of 1 over 9 plus v squared dv is equal to the integral of negative 1 dt. Now, this integral here can be done by substitution. You should actually have done this one, and you can always go back and verify. When we integrate that, we get 1/3 of the inverse tangent of v upon 3. And that's going to be equal to negative t plus some constant. Now, v is equal to u when t is equal to 0. Therefore, 1/3 inverse tan u upon 3 is equal to c. And therefore, t, just taking this onto the other side, is going to be equal to 1/3 inverse tangent of u upon 3, take away 1/3 inverse tan of v upon 3. So, particle comes to rest is v is equal to 0, and that means, since this would be equal to 0, this term here, that t would be equal to 1/3 inverse tan of u upon 3. Quite a nice version of this question is when v is equal to 3, and then you would have inverse tan of 1, which is pi by 4, and your answer would be pi by 12. Okay, let's move on and let's look at the value of x when the particle comes to rest. So once again we have that a is equal to negative 9 plus v squared, and that means that v dv dx is equal to negative 9 plus v squared. Separate and integrate gives us the integral of v over 9 plus v squared dv is equal to the integral of negative 1 dx, and we can write this one as a half the integral of 2v on 9 plus v squared dv, and that's equal to the integral of negative 1 dx. And then we have the situation where the numerator is the differential of the denominator, and so what we're going to have is a half ln 9 plus v squared is equal to negative x plus a constant. Now we know that v is equal to u when x is equal to 0. And so we would have, actually before we do that, what I'm going to do here is I'm just going to multiply through by 2. Do I need to do that? No, I don't need to do that. So I'm going to do half ln 9 plus u squared is equal to c. And that would give us that x is equal to, I'm just going to take the x onto this side, that will give me a half ln 9 plus u squared, take away a half ln 9 plus v squared, and then using a log law we can say that is a half ln 9 plus u squared divided by 9 plus v squared. And then all we need to do is look at when v is equal to 0, and x would be a half ln 9 plus u squared over 9. And again, we mentioned that v equals 3 gave a nice answer to the last part, and here it would just give us a half ln 9 plus v equals 3, not u, and it would be 9 plus 9. It would be a half ln 2 basically, if that was the case.